Hello, Dr. Rogers, and welcome to Computer Science Chats. How are you?
I am doing well. How are you?
I'm doing well as well.
That's
Thank you.
good. That's good.
I have several questions for you.
Okay.
First, could you please introduce yourself and your educational background?
Okay. My name is Michelle Rogers, and I am a program officer at the National Science Foundation. My educational background is that I went to a technical high school in Brooklyn, New York. After that, I went to college in Atlanta, Georgia, and I attended what was called back then, it was a dual degree program, meaning that you went to a liberal arts college for 3 years and then you went to a technical college for 2 years. So I went to Spelman College, which is a historically Black university, for 3 years. And I went to Georgia Tech, which is a technical school. I did that and got my bachelor's in electrical engineering, actually. And so but during all that time, we have to take computers and learn all about that. And then I went on to graduate school at the University of Wisconsin, Madison.
Thank you.
You're welcome.
What is it that inspired you to pursue computing as a career?
I think that early on, I, been using a computer since I was your age, I guess I could say. And always found myself interested in them, used them a lot, started coding fairly early, programs that are pretty much not around anymore, but still did that. And when I got to graduate school, I became more interested in how computers support people's work. So a lot of my research looks into how computers support people's work. But in the design of computers, sometimes we can design them not taking into account all of the things that people do in their jobs. And so part of the research that I do looks at matching what the computer can do and how the user actually uses it.
That's very interesting.
Mhm.
Could you please describe some of the activities that you do through your work at NSF?
Sure. So at NSF, what I actually do is look at proposals that people send to NSF seeking funding, right? So the foundation is the citizens and the government of the United States providing money for an agency to then support research throughout the United States. And so the work that I do is to look at those proposals and to see and understand, help people understand, to be able to decide whether or not what they have proposed is a good idea. So that means I contact people who are experts in the area. So whether it be security or artificial intelligence or machine learning, I get those experts to come together, usually in groups of 5 to 8 people, and they look at these proposals that researchers from across the country have submitted. And we look at those proposals and we try to determine whether or not they're innovative and new. We look at, are they prepared to do this work? Do they have the expertise? Is their institution, does their institution have enough equipment and facilities to support that work? And then do they have a plan to tell the world about the work that they did once they finished and that they can evaluate it? So not only do we give them support to do the work, but we also want to make sure that they can tell other people about it. In some of our work, we ask that they involve students. So some of the work, if they apply for experiences for undergraduates, we ask that they include undergraduates or graduate students to keep the work going.
Thank you.
Go ahead. Mhm.
What do you like most and what do you find challenging about these activities?
So I like getting to know the community, getting to know people and what work they like to do. It's exciting to be able to see where the field is going, like what people are interested in researching about, and how they're including students, how they're including communities that may have not been represented in years past. So I like that part of it. The hard part about it is making sure that all of this gets done on time, right? So we have to ask people to send us things in on time. We have to make sure they're in order. And so sometimes you have to turn people down. You have to tell them you can't support their work. And that's always not a good thing. You don't have to tell them we can't support them. But the good part is we try to help them get better.
That's very interesting.
Mhm.
What advice would you have for high school students who would like to get into your field?
I would say to be curious, to don't be afraid to try. And if you're interested in different things, so like if you're interested in how things work, to find a way to learn more about it. Nowadays, there are so many online resources that you can try and get to know other kids like you that are doing that kind of work. We all know that there are academies online where students can learn more about coding or even just using computers. So when you use, TikTok or just use your phone or, whatever it is that you use with your computer, you can think about how does that get there? How does it get done? If you have Alexa, any of those types of things, you can think about how those get done and you can learn more about, making them happen.
Thank you.
Mhm.
So if somebody is trying to understand computing careers, how would you describe the difference between a research and an industry career path?
Okay, so an industry path usually would involve you investigating different companies that you would like to work for, possibly seeing if they have an internship or applying for a position once you've gotten the skill level that you need. And so on the industry path, you're usually working on something that either exists already or is in development, and you can be making it better. You can be designing aspects of it, things that you see on television, things that you use on your phone, on a laptop, a program that you see developed. Whereas a research career, you can be trying to understand how people use those things, how people, what makes them go faster. If you are interested more in what we call the hardware side or the physical device, you might be interested in the chips that go into your actual phone or into your laptop, how the board that runs all of your inputs, how that runs, how do you get the visual output? Those things are also computer science, making those better. And so you can, in research, you can learn about why and how to do those things. And then in an industrial career, you would be able to actually use them. And even if you want to go up the management, the management or administrative track, you can be more interested in how do we make a business around what it is that we've discovered. So if you want to develop a company that uses computers to do something, you could eventually, if you want to start a business around that idea, you would use your computer science background to, as well as some business experience you have, to then grow it. You could do that, even now. If you think about, you could develop an app to do some function that you see people have a need for. Then if you're interested in business, you can think about how you can make that available to the public, available to a public service or to a government, to a city, and then how you develop it from there.
Yeah, I know that you mentioned underrepresented communities a bit earlier. How
Yes.
can I, as a high school student interested in computing, help in advocating for a more diverse and inclusive field?
So I would say in the choices that you make and what you choose to do, make sure, or just be aware. How about that? You just be aware of who in your class is participating, who feels like they're not asked to be on a team, or that's one way. Another way is to think about yourself as you think about when you make decisions. Are they based on ideas that maybe you saw on TV or people around you may have said. So maybe in your computer science class, there might not be a lot of girls in the class. For whatever reason, there are lots of different reasons why there are not girls in your class, but you as a person in your class that may not identify as a girl, you could help others around you to not support making the girls feel bad or feel separate or feel like they don't belong. And so you can encourage your friends to welcome, everybody to your class, that we could support each other as a group and not be misled by what we see on the outside or what we hear other people say that are not, involved, but that knowing that your friends are everybody, especially in a school that is reaching for good students. You want to make sure that all the good students are in a place that they can come and feel comfortable. And so your part is you can help people feel comfortable.
Thank you. That's very
You're welcome.
insightful.
Mhm.
Where do you think that computing is going to go in the future, and how can students prepare for it?
I think the best way, I think the first thing they should think about is whether or not it has to be done by a computer, right? So just because I can do something doesn't mean I should do something using a computer, right? So as we think about, the possibilities are seemingly endless of what is available to students in the future with computing technology as it exists now. And so we know that it'll enter areas of our lives where maybe we don't want Alexa always watching or listening to what we're doing. But if it is, maybe we can figure out ways to make that more helpful. So I think that, at least in Western societies, we are not as comfortable with artificial intelligence and devices helping us. But as our populations age and people are still working outside of the home, we might need to be able to begin to use not necessarily a robot, but you might need to have a device that could keep an eye on an elderly parent or keep an eye on a family member who has special needs, that they can stay at home by themselves, but there's certain things you just want to keep an eye on. And so part of the future will be, how do we design technology that people are comfortable with, but that are not so intrusive that take away people's right to privacy and right to their own existence. So I think that as computers begin to go into different areas of our lives, we need to be aware of that at all times. So we should not lose sight of the ethics of what we're doing, what it is we're capturing in terms of data, and then making sure that how we capture data and how we capture information does not cloud what we know to be true, right? So we know there are some things about technology that only work based on the data that we put in it. So we have to make sure that the data that we put in it doesn't have the same biases that we have, doesn't pick up on the inequalities that our society already has. So we have to try to make our technology more equitable and available for use by as many people as needed. I think that's about
Yeah. And connecting to my last question, how would you describe the future of computer science education?
education. I think we're trying to get better at helping students understand what goes on, in a programming language. So I think we're going to be making decisions about what's the best way to teach that, what's the best way to help people grow in that. We're learning more and more about how to introduce different populations to computing in ways that they feel comfortable enough that they pursue it further, so that we're not driving people away, but helping people see an entry point and be able to enter there. And so a lot of times with education, it's been based on a model of, a teacher speaks, a student receives, and then the student regurgitates what they heard. The last 100 years, I can say we've kind of gotten beyond that model slowly to where the student now can have problems to learn. They can use projects to learn. There's other ways to get concepts across, and they can help the teacher understand how best they understand things. And I think as we reach more neurodiverse students, we are going to have to expand the way we teach computing in order to meet the needs of our different populations. And that might take us a bit, but I think we can. We have the education and the tools to do it. I think we just have to do it.
Thank you very much for meeting with
You're
me
welcome. Thank you,
and for
Victor,
being
for
willing
doing
to do this interview.
Thank you for doing the interview. This is a really creative idea.
Thank you.